we were just getting an overview of how routing actually works. And we considered the scenario by having R1 there, then by having R2 there, then by having R3 there, and then if we have certain scenarios like this itself, and if we have some networks, and then a couple of PCs connected, then 1.0, 2.0, 3.0, 4.0, and 5.0, considering 192.168 as the first two octets of all of them. So we saw that if we kind of take a look at the routing table of R1s, then there would be kind of couple of directly connected routes with the annotation of C. And you will have the C routes as 1.0/24, maybe let's say connected on FA0/0 and FA0/1, like that. Then you would have C and C as 1.0 and 4.0.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
And those are connected to FA0/0 and FA0/1. Then you can add the static routes for 2.0/24 going out on FA0/1, and you can add the other for 5.0/24, same interface, and another static route for 6.0. Oh, we don't have any 6.0. For 3.0/24 on the same interface. These are kind of called as static way of adding the routes into your routing table. But this is not kind of an efficient way about how routing actually needs to be done in a bigger scenarios. So what we do is we take or explore alternatives or different ways of implementing routing in our scenario. So when we actually talk about routing, as I said, that the routing is divided into two parts. You can say one is called as static routing and the other one is called as dynamic routing. And if you talk about the static, we have seen certain methods about implementing static, which is static, like normal static, then default static, and then we also have seen about floating static. Now we are going to look at the dynamic way of implementing routing, in which one of the protocol, which is not, I would say, the official curriculum of Cisco CCNP, but it is important one to talk about, RIP. The second one, which is available called EIGRP. The third one, which is available as OSPF. Okay, and we are also, so these are going to be IGPs, interior gateway protocols, and then we will also be discussing about BGP as one of our EGP protocol, exterior gateway protocol. So today's class is going to be about RIP, and we're going to talk about RIP, and then we will also see a lab about how we can implement RIP there, and then we will see how we can take it further. So when we discuss about RIP, then as it is kind of part of dynamic routing protocol, I would like to just go for certain fundamentals about how RIP can be assumed in this way. So I'll just kind of get rid of this and then take this topology somewhere over here, where then I can talk about routing information protocol. So when we discuss about routing information protocol, there are some fundamentals that you need to be familiar with. First one is that it is an open standard protocol. Okay. Second, it is now classless routing protocol, and I'll be explaining all of the terminologies. Third, it is that the updates that it uses are sent on 224.0.0.9. Fourth parameter is the metric in RIP is hop count. Then the fifth one, or the fifth parameter here, is the load balancing of four equal paths is supported. Then the maximum or the max, oh sorry, the max hop count is 15. Then 7, it is used in small organizations. And eighth is it exchanges, or you can say, instead of saying this, you can say it works on periodic updates. And 9, you can say the administrative distance is 120. There, these are kind of the parameters or the important factors that we need to discuss about this. So how we go for that is, it is basically an open standard protocol, which is not really a big deal. Almost every protocol that we are working so far in the network environment has, I would say, an open standard protocol, like uses the open standard protocols, which means you can have one of some of the devices of Cisco and some of the devices of some other vendor, be it Juniper or Palo Alto or something like that. And then you still can implement RIP, and your network can be converged by using these protocols. Then, after that, if you talk about, I would say, the second property, it is a classless routing protocol. So, RIP had two versions. RIP had version 1, and RIP also had version 2. If you talk about version 1, it was having a behavior of classful routing protocol, which means the networks that you're working with 1.0, 2.0, 3.0, 4.0, and 5.0. All of these networks were needed to be of the classful nature, which means they could be of /8, /16, and /24. You could only advertise the networks if they were of /8, /16, and /24. If you would have configured a network with, let's say, /27 or /17 or /12, then your RIP would not advertise the paths according to the prefix length of what you have for a classless nature. But this drawback was overcome into the version 2. That's why the RIP version 1 is said to be of the classless routing protocol, where you can have your subnetted networks configured in your topology, and your RIP will be able to advertise them as they are. So that's the second property when we talk about it. The third property, however, says that the updates are sent on 224.0.0.9. So this property, which is property number 3, and then this property, which is property number 9. Both of these properties are kind of important and pretty much important over here. That when you have a scenario that your R1, R2, and R3 are configured with the IP configuration, then how it's going to work is, you now won't be adding the indirectly connected network into your routing table. Okay, so the dynamic routing protocols allow you to advertise your directly connected networks, and then the other routers that are present into the topology will be getting that advertisement on a multicast address, okay, like a class D address. And then the routers will kind of learn about the updates, and then it will try to add those learned routes into the routing table if the criteria matches up. So, like, if we compare the scenario with the static routing, instead of adding 2, instead of adding 3, and instead of adding 5 into the routing into the router 1's routing table, what is going to happen is the 1 and the 4, both of these routers are going to be advertised to R2 and they are going to be advertised to R3. But that's not going to be a unicast advertisement, it is going to be a multicast advertisement where the people or the routers that are participating into RIP domain will be getting those advertisements, and then they will kind of have that particular route installed. So R1 is a R1 and R2 are going to advertise 1.0 and 4.0. R2 will be advertising 2, 4, and 5, and R3 will be advertising 3 and 5. And that's how every other device that is present into the topology just needs to update their directly connected network. If we compare it with a scenario of static route, it is possible that if you have a network of, let's say, around 10, I would say, routers, then in that scenario you will kind of need to like add every routing information on every router by using static route, and which would kind of be a pain. So you can say instead of doing that, you can go ahead by using dynamic routing where the information will be dynamically learned by the routers. Cool. So that's why when it works according to the behavior, then all the routing information is actually sent by using this class D multicast IP address, which is 224.0.0.9. So when you configure RIP and it will start advertising your network, this is the destination address for the update that's going to be. Okay. And then after that, so when you're going to say that it works on periodic updates, what it means that the updates that we're talking about that are actually going to be sent on to 24009, those updates will be sent every 30 seconds. Every 30 seconds. Which means the R1 and R2 will be advertising our 1.0 and 4.0 to R2 and to R3. And then the R2 and R3 will kind of will be advertising their directly connected networks to R1 and R2 and R3 respectively. And then these routers will keep on forwarding the same information again and again and again and again every 30 seconds, which kind of uses a lot of unnecessary bandwidth of our network. There's kind of a lot of unnecessary traffic that is flowed across the network that is just to keep the network up and running. Okay, which is kind of a drawback over here of RIP because there are better alternatives that are available. But yeah, this is how it works. And then it says that the metric the metric in RIP is hop count, which means that when your route is actually going to be added into your routing table, just unlike static route, it doesn't really consider the route that is prioritized with the help of metric, because in I would say a static route you can manually provide the metric like what we have seen into the floating route, right? You can prioritize a route based on the information like that. But over here, if you kind of have a scenario, let's say you have R1 there and then you have R2 there. Okay. And then in order to reach out to a network, like there is a loopback here, there is a loopback here, and then you have another router called R3 which connects to R2 again. So in order to reach out from here to here, you have two routes. One is going this way, the other one is going this way. So which one would you take? Now, when you look at the R1's routing table, let's say that the networks that are connected are 12.0.0.0, then you have 13.0.0.0, and then you have 23.0.0.0. Okay, and then the loopback is 20.0.0.0, and over here 10.0. So when you look at the routes that will be added by using RIP onto R1, on R1 the route will kind of look like with an R tag, and then it will give you an information that the network is added by using 30.0.0.0, and then it will kind of have an AD value of 120. We'll be talking about what is AD, and then slash it will contain something called metric. So this particular value is metric, and metric and for RIP or metric for different protocols can be a different value as well. Over here in RIP, the metric is hop count, which means the criteria that is considered for a route to be elected as the best route is the number of devices that it needs to cross in order to reach out to the destination. So if you look at R1, R1 reaches out 220.0.0.0, if it uses the first route via 12.0. So the hop count over there for the first route is it just needs to reach out to the destination by crossing one router, which is R2. But if you look at the other way, then the other way as well can be reached out by using 30.0.0.0 by using same AD. But the metric in that case is going to be 2 because it needs to cross R3 and it needs to cross R2 as well. So that's how different hop counts can, or that's how different the metric can be in terms of this particular topology. So when we talk about the metric in RIP is hop count, this is exactly what we mean. The metric means how many devices do you actually need to cross in order to reach out to the destination, and that's what the metric is for RIP. And different protocols, the metric can be different. Over here, it is a hop count. So that's something that we have there. Then we talk about load balancing of four equal costs or four equal paths. What it means is if you have a scenario that the destination network is reachable via, for example, if you have R1 again, and then you have R2, and then you have R3, then you have R4, and then there R5, and then there R6, R7, and then there. So if you look at this, how many routes do you have there in order to reach out to the R3's loopback? You can reach out by using the primary route. You can reach out by using secondary route, the tertiary route, and the fourth route that's available. So in this scenario, it is only going to add this, this, and this, okay, inside your, I would say, network there, or inside the routing table of R1. It is not going to add the fourth route because it is not, I would say, of the equal path or the equal cost. When we talk about equal cost, which means in order for the candidate routes to become eligible to be installed into the routing table, your route metric should be the same of the lowest metric that is available. So the lowest metric or the lowest hop count that you have is 2 hops away. And the criteria of 2 hops away is matched by the first route, the second route, and the third route. But it is not matched by the fourth route. So that's why the fourth route will not be inserted into the routing table. And you only have the first 3 routes being installed into the routing table. Make sense what I'm talking about? Any question here?
No.
Okay. Yeah. So that is exactly what it means when we talk about the load balancing of four equal paths. So and after that it says that the maximum hop count is 15, which means that your router cannot actually cross a boundary of, I would say, reaching out to the 16th router. So it's like this R1 to R2 to R3 to R4 to connecting and connecting and connecting. It can go till R15 in sequence. So it's like 1, 2, 3, and then to the 14th, then it can also go to R16. Okay, so that's how far it can go. But if you have serially connected routes as R17 and then R18 like that, then the route that is actually being advertised by R1 will only be installed till 16th router in the row. Okay, the R17 and then R18 will not be able to install the route that is advertised by R1 into the routing table of R17 and R18, and so won't be able to like R1 to add the route that is advertised by R17. That's kind of a limitation there, which means the route that you're advertising can only travel till the 16th hop, okay, from the current router, or you can say the maximum hop count is 15 there. That's something, the scenario that you need to consider. And then it is definitely used in small organization, and it works on periodic updates. As I said, that it exchanges the entire routing table every 30 seconds there. And the AD that is used, administrative distance, is 120. So what is this AD? When you talk about this AD, AD stands for administrative distance value, and by default it is set for almost every protocol that is out there. When we talk about AD, AD stands for administrative distance. Cool. So if you talk about the connected routes, then the default, the administrative distance is 0. When you talk about the static route, we say that the default, the AD is 1. Then if you talk about, I would say, EIGRP, so far EIGRP has two ADs. One is called as 70 and the other one is, no, sorry, EIGRP has two ADs. One is 90 and the other one is 170. And then the RIP has an AD of 120 and OSPF has an AD of 110. Okay, so if let's say for creating a connection, if you have R1 there, and then if you have R2 there, and then you have R3 there, and the entire domain is kind of also configured with RIP and EIGRP. So which routes your router is going to prefer in order to install? It is definitely going to prefer the EIGRP route because EIGRP has a lesser AD than the AD of RIP. Okay, so the administrative distance value that is set for RIP is called as 120. That's something that you need to take care of.